it over to Mr. Robbie.
All right, Mr. Roloff, anything you want to add? Otherwise, we're gonna.
Go right ahead.
All right. Thank you, council, and anyone who's watching either live or on the recording for tuning in today. As we talked about, this is an update, status update on a lot of the additional investigations that we have requested Jacobs Engineering to do on behalf of the Clearwell project. So I think with that, I will just turn it over to Linda Moore to jump right into her presentation. And, I think as always, if you have questions as we're going, please just blurt them out as we go. No need to save them till the end. And with
Thanks,
that,
James.
Linda, go ahead.
Thank you, James. And thanks, everybody, for making time. As James mentioned, we were last addressing the Common Council about 6 months ago in March about this project. And since then, we have followed through on the DNR's suggestion that the city could investigate whether it was feasible to extend the service life of the Clearwells, specifically by conducting inspections of the Clearwells. And in addition to that, the city undertook some groundwater sampling to look for water quality contaminants in the groundwater in the vicinity of the Clearwells. So what we're going to talk about tonight is discovery this spring and summer, and how we've coordinated, communicated with Wisconsin DNR, what would be involved in repairing and rehabilitating the Clearwells to extend their service life. We're going to touch on the alternatives for the Clearwells project, the compliance schedule that the city proposed and the DNR has accepted for this project, and what we envision our next steps being as part of the project technical delivery team. So, in May or June, when the groundwater thawed, the city hired a Clearwell inspection professional, a company called Dixon Engineering. They've also done inspections for the city on elevated water storage tanks. And their engineers and Jacobs engineers reviewed the condition of empty Clearwells together, and Dixon prepared reports that were submitted to DNR, inspection reports, and a lot of the photographs that you see in this presentation are from Dixon's work. So in the early summer, spring, we were conducting those inspections and installing groundwater monitoring wells near the Clearwell. In June and July, we submitted the inspection reports, and again, we collaborated with Dixon on that and worked together as engineers on what would be feasible repair strategies and rehabilitation approaches for the Clearwells to extend their service life. The water utility staff at the treatment plant collected groundwater samples and had them analyzed for many compounds that are regulated under the Safe Drinking Water Act. And then in August, earlier this month, we reviewed those findings with the DNR, and we're here with you this evening. So, Clearwell inspection findings. The Clearwells, as you know, are partially buried water storage tanks. They were constructed on a rock-like formation. It's commonly referred to as hardpan in town, and that provides a very good structural foundation for these tanks, and probably one of the reasons why there are in fair to good shape, even the really old structures that are there. These photographs show the kind of corrosion that is evident on the surfaces, concrete and metal surfaces in the Clearwell. And this kind of corrosion is not uncommon when these materials are exposed for many, many years to chlorinated water. Previously, and I don't know the exact year, plant staff guess it might have been somewhere around the 1960s, The clear wells were relined with a material called shotcrete, and shotcrete is a cementitious lining. And a lot of that lining is in poor condition. Parts of it have fallen away and been removed. Parts that are still remaining on surfaces are damp in areas, which indicate there's cracks or leaks that could be masked behind that remaining lining material. So we put together cost estimates to remove this material and repair these cracks, but kind of had to make a expert guess on what would all be involved in that work, because not every surface was available for us to inspect. Some of the concrete surfaces are soft, a little spongy in nature. That too is not unusual for concrete tanks that have stored chlorinated water for a long time. It's not an appropriate material to build upon, so we would have to remove that before we would put any kind of repair lining on. And the water storage tanks have pipelines that convey water into the tank and water out of the tanks. And these wall pipe penetrations leak, some of them more actively than others. The photograph here on the lower right of this slide shows a wall pipe penetration that has been previously repaired. That lighter color concrete indicates where the wall had been previously cut away, and the wall pipe had been replaced at one point. At this location, there was an active water leak. There were active leaks visible, photographed, videoed in both the north and center clear wells. And as a result of these detected active leaks, the city has changed how they're operating the clear wells so that the surface water elevation of the stored drinking water is always above the water table. And what that means is there is a positive head, a higher potential energy, so that if water is going to flow through a crack in these walls, it's going to flow from the inside of the tank to the outside of the tank. As opposed to when they were empty, like these photographs, there was no pressure keeping that groundwater back, and the groundwater flowed in these locations. All right, in the spring, with the help of AECOM, there were 2 groundwater sampling wells installed at the filter plant site, one east of the clear wells, one west of the clear wells. They were installed of all PFAS-free materials of construction. And this summer, 3 rounds of samples were collected for over 170 Safe Drinking Water Act regulated contaminants. These included microorganisms, disinfectants, chemicals, organic and inorganic, radionuclides, PFAS compounds, and other water quality parameters. Of the PFAS results, there were 20 different compounds measured, and the majority, like 90% of the results for PFAS in the groundwater next to the clear wells, not in the drinking water, but in the groundwater, about 90% of those results are below the detection limit. So the sample result comes back ND, non-detect. And then for about 10% of the compounds tested, there were results that came back with brackets around them, very, very low numbers. The brackets were a way for the laboratory to communicate that they had uncertainty about the measurements. They thought the parameter was there above the non-detect level, but below what the laboratory professionals call the level of quantitation. So they reported a number extremely low, a lot of uncertainty. So not a contaminant of concern in the groundwater at this location based on 3 rounds of samples. So what were the concerns? The concerns that were found through groundwater sampling were positive detects for coliform, for fecal coliform, and what is often referred to as heterotrophic plate count or standard plate count. And what that measures, and this parameter is measured in terms of coliform forming units per milliliter. What that measures is a level of biological activity. And the city is constantly measuring heterotrophic plate count, but primarily out in the distribution system because they want to make sure there aren't areas where there are biofilms growing on the insides of pipes out in the distribution system, leading to a potential contamination event or just a water instability situation. So in the drinking water industry, when we see detects above 500 coliform forming units, we know that there's biological activity going on.
Can I ask when were the sampling results done?
The samples were collected in June and July. The results were conveyed to the city in July and August.
And it's important to note, as you mentioned, these are all the groundwater samples. This is not drinking water samples. These are all the groundwater samples taken from the groundwater around the existing structures.
So would that be normal then to have, if it's from the groundwater and not from the distribution, would it be normal to have these, you sort of have concern, these coliform and fecal coliform and standard plate counts to be in the groundwater?
At that location, yeah, you're right by a beach. You have a lot of seagulls. You have a lot of people. You have people walking their pets. You have shallow groundwater.
Lots of geese.
Geese. There's wildlife
She
there.
just cited reason number 1.
There's wildlife there. This is coliform and fecal coliform are a common reason why beaches are closed in the state in summer.
Just out of curiosity too, in those collection of test results, I think I have the word right, I'm not sure. The one that's related to the algal bloom contamination with, is it mycostatin?
There is a toxin, yes. This round of samples did not look for algal toxins. I believe the city participated in a study with the University of Oshkosh several years ago where students at the university were involved in a project looking for algal toxins in Lake Winnebago. This might have been around the time that there was a problem in, was it Toledo, that had the big
Yes.
green bloom?
Yes, yeah, water utility did participate with DNR and the university on doing cyanotoxin testing around that time, but that was separate. That was testing out in the lake. This being groundwater is not something that you would normally be looking for in the groundwater, right, Linda?
That's what I
Correct.
was curious about, is whether
Yeah.
that was part of this, okay.
But you're right, it is an emerging contaminant. It's one that fortunately the city's treatment process is well designed to treat and remove.
But maybe not swimming at the beach.
But we still have the testing done at the beach, and the beach wasn't closed this summer. I don't believe it was closed once, but
Yeah.
sometimes good to be lucky, and I think we had a lucky summer.
Okay, so we collected all of this information and met with DNR. And this slide is one that I've reviewed with DNR to confirm that we are expressing their guidance accurately. So, a buried clear well is a buried water storage tank that's located below the groundwater table and below the floodplain. And if your buried clear well is watertight, it still does not comply with NR 811. So, if a buried clear well is watertight, what the DNR will prescribe is, or how they will respond is they will permit operation of a non-compliant tank as long as the operators of that tank undertake additional safeguards. One thing they specifically mentioned was frequent inspections, dry Clearwell inspections.
Real quick, is ours considered watertight?
No.
No.
Didn't think so.
Active
Okay.
leaks, no. The
Before the
Oshkosh
test was
Clearwells,
done,
Yeah.
before the test was done, there
could
was,
assume.
we could,
She's not going that far.
As Linda works down the table, our situation falls under the last row. But Linda is just kind of describing the various opportunities, but we fall under the last row right now.
and it was very helpful for us, for the DNR team, to articulate how they approach this particular part of community water systems. So, if your buried clear well needs standard maintenance, maintenance would be a project like doing concrete crack repair, so that you can take your clear well and restore it to a watertight condition. That's considered maintenance. That's not a project for which the city has to prepare drawings and specs and submit them to the DNR for their review and approval, because it's a maintenance project. So in that case, again, the DNR will allow the operation of the crack repaired, non-compliant tank, provided additional safeguards are followed. Now, the last possible path is the one that Oshkosh is on. So, a buried clear well that needs major repairs, including concrete crack repair to restore watertight condition, replacement of interior lining to mitigate corrosion, and/or addition of a sloped membrane roof. That's considered a major capital project, one that the city would submit drawings and specs to the DNR for review and approval. And just like any other facility at the treatment plant, let's say, for example, a chemical feed system where the city wants to replace a storage tank and a feed pump. That project, when the DNR gets that project for that chemical feed room, they're going to look at that chemical feed room and bring it up to code. They're going to say, you know, your eye wash and shower has to have tepid water in it, not cold water. So we know you're doing your tank and your pump, but make these other, address these other deficiencies, because you have to be brought up to code. The same thing happened 10 years ago when the raw sewage pumps at the wastewater plant had a big drive replacement project, and pump motor and drive replacement. Well, then we had to bring electrical in that area up to code, because many, many years have gone by, and it's like when you touch something, you have to bring it up to code. So that's their position on clear wells. So they said two possible options for a clear well that needs these major repairs is make those major repairs, restore water tightness, and add another disinfection process downstream of the clear wells to achieve 4-log, which is 99.99% virus inactivation. Or you can replace those tanks with at-grade tanks and a pump station that would fill those at-grade tanks.
So these are the additional safeguards that would permit a non-compliant.
Yep.
Yeah, the additional safeguard would be adding the additional treatment system downstream.
And probably more frequent inspections, dry inspections.
Right.
Linda, question for you, because we had not been doing inspections in recent years because we were anticipating doing the Clearwell project, and we got a waiver to do those inspections. So this is why, things have deteriorated, because it's been a while. When this was last done, was that your company? Was that you that was part of that inspection that was like 2014 or?
2014, another outfit, also a company called Preload, who also does these repair, or these inspections, similar to Dixon Engineering. It's in their wheelhouse. That's a big part of their business. They conducted and documented the inspections in 2014.
How would you characterize that inspection in this slide here? Where would the Clearwells have been at that time in 2014?
Definitely the second bucket, not the first.
Okay, not the first, but the second bucket. Okay.
Right.
So,
Right.
but since the momentum had been gaining for doing a Clearwell,
Right.
it was like, well, we know you're going to replace it, so we're not going to require you to do anything major.
Correct.
Yeah, I just wanted to kind of frame that for everybody where we were in 2014.
I know we had this discussion about the DNR having to give us a waiver to allow this. So is that a sure thing then? If we take these steps, they'll let us do it for number one?
Yes.
Okay, there's no.
Yes. In fact, they have precedent in other states or other communities in this state where they have required this additional disinfection process, and that's the path that the utility took.
Thank you.
There's more to come with that. The other part of that question, that's a loaded question, even as basic as it was, because as Linda will show you, there's more to it than just can be done, but at what cost?
Okay, so moving on, we're going to have 2 or 3 slides talking about what does repair and rehabilitate the clear wells mean, what would that project look like with the additional treatment barrier, and then we'll touch back on what were our project options last fall and in the winter with at-grade reservoirs and pump stations. So, to repair and rehabilitate the clear wells and meet several of the current deficiencies, the interior surfaces would be blast cleaned so that the surfaces could be relined with shotcrete. The wall pipe penetrations would need to be repaired to restore water tightness, or replaced to restore water tightness. And clear well overflow pipes need to be added to each clear well to permit the free discharge of overflowing water from the storage tank. Your other storage tanks in the city, your water towers, for example, all have overflow pipes. So once the surfaces are cleaned, cracks can be repaired through the injection of chemical grout, unless it's a major leak, in which case there are temporary drains that can be installed and route that drain flow to temporary sump to create dry conditions to complete the repairs in the clear wells and do the relining and be able to make sure that the work, the environmental conditions are appropriate for successful completion of this work. We already touched on cleaning and shotcrete. The earthen cover would be removed from the top of the clear well. So there's about 6 inches of soil and sod up on top of the clear wells today. That would be removed, and a new membrane roof that's sloped would be installed. And with that new roof, personnel access hatches and code-required security type vents would need to be reinstalled. And in the clear wells now, there aren't interior baffles that make the water flow in a serpentine path. And because of that, the clear wells can experience hydraulic short circuiting, which means that the new water could like cut in line and leave the Clearwell before the older water. So all of the new storage tanks, including the CT backwash supply basin that's on site, the at-grade reservoir designs that we've talked about before, they all include baffle walls so that the first water into the storage tank is the first water out of the storage tank. Fresh water is really important because as water age increases, water quality diminishes. So interior baffle walls would be added to the Clearwells.
What happens with that water quality exactly? Like, in what way does it diminish?
What happens is the Clearwell, the chlorine residual, the disinfectant residual, it's a chloramine residual, it degrades faster. You can have faster biological regrowth. In the summertime, you can have nitrification increase. All of these water quality parameters that are declining have the potential to increase your lead and copper corrosion. So when you can keep a good chlorine residual, when you can keep a stable pH, you can keep a stable alkalinity, all of those things contribute to maintaining water quality out in the distribution system that has what we strive for is optimized corrosion control, which is send out really good water and then watch it out there and address it if you see things that aren't spot on. Okay, so you might say, well, you know, if we extend the service life of our Clearwells, could we extend the service life of our high-lift pump station? There's a high-lift pump station that was constructed in 1985, so it's coming up on 40 years old. And that pump station does not have the type of pump drives that are needed. They're constant speed drives, they're not adjustable. So the high-lift pumping requirements, the functionality of having adjustable frequency drives, of having enough space to install flow meters so they can give very accurate measurements, are not things that can be done within the 1985 pump station, and there isn't space next to that station to expand it. So similar to the at-grade reservoirs, we would propose to put the high-lift pump station in the center Clearwell, and this red cartoon on the right shows how water would flow from the north Clearwell and from the south Clearwell into pump station wet wells. Then the pump would pump into three water lines that have flow meters and UV reactors in them. And then from that system, they would connect to the existing two finished water transmission mains. There's a 16-inch and a 24-inch that leave the plant and serve the city. And that space in the 1985 pump station where the pumps are is a great size for what we call a surge protection system. It's like a shock absorber, and what it does is it dampens out hydraulic surge or water hammer. And when you do that, you can reduce the number of water main breaks that you have. So the city doesn't have one of those now, and it's something that the city would like to incorporate at the plant. And then, as we talked about, we would be adding UV disinfection downstream of the Clearwells.
How far downstream would that be?
Right there in that footprint, it's like 85 by 60, so it'd be all in the
It's
same big
still
building.
within the site, not like
Yeah.
literally downstream.
No, it would have to be on the site before the water leaves the filtration plant site.
Correct, before the first customer. So, advantages of extending the service life of Clearwells is that you maintain similar visual impacts, although at center Clearwell, there'll be a big pump station and UV disinfection facility. And another advantage is you don't have to construct and operate and maintain an intermediate pumping system to fill the tanks. They can fill by gravity. The disadvantages are the city needs to construct, operate, and maintain a new treatment system to achieve 99.9% virus inactivation. Another disadvantage is, although we have the technologies and tools to do concrete crack repair and reline existing structures, we're still going to be repairing 120-year-old concrete. So there's just some inherent risk. It's not the same as new. So it would be, we should be mindful of that, and the fact that at some point in the relatively near future, there's going to be more cracks to repair. And so there's
And does some of
future
the-
investment.
Do some of the circumstances or situations that impact that, like, have to do with the, maybe extreme difference in cold and heat and some of our fluctuations, like we see with roads?
Oh,
I don't think as much. It's in the concrete industry. It's well known. Concrete cracks. That's just the nature of concrete. It cracks. In the case of the roads, you're right. When you get the extreme heat, that causes it causes the concrete to expand a lot, and that causes a buckle and an upheaval. In this particular case, you're not seeing that as much as you're seeing cracks, but you're in a situation where there is a constant ability for chlorinated water to be moving in those cracks to exacerbate those cracks. I don't know if you had any other thoughts
Yeah.
on that, Linda?
well, that and the tanks are buried, and we know the earth provides some insulation.
Gotcha.
So
Okay.
I would say that the lower part of the tanks are pretty well insulated by earth and whatever groundwater condition there is, freezing or flowing. And then the little layer on top is much more susceptible to expansion and contraction that would result from temperature extremes.
And wouldn't that be true too then for the above ground alternatives?
Well, in the above ground alternatives,
Sorry, I didn't mean
no,
to
no, no.
jump ahead.
No, that's fine. That's fine. It's a great question. So in the above ground alternatives that are constructed of concrete, the way that we today deal with mitigating cracks or big cracks from forming is we install water holding structures with expansion joints, with waterproof expansion joints. And do they last forever? No. The city has done projects at the wastewater plant where they've replaced expansion joints in 1970s concrete, within the last 10 years.
I think we got some going on at water filtration too with the DMFs. I think we've got some concrete repair work going on there too, which is mostly joint work, and the SED basins, I think, too, right, Linda?
Yes. Well, the SED basins had crack repair and expansion joint replacement. So,
Also have to remember, these are filled with water constantly circulating, so there's a cooling factor built in with the water and a stabilization to help kind of prevent that just baking in the sun all day on a flat slab of a road.
I was still thinking about the discussions from the last time about the differences between the stressed round and, or I'm sorry, round versus the stressed square. So that was just kind of running.
yeah. Well, unfortunately, the buried Clearwells were constructed before we had the techniques that we have available to us today. So it's not really a fair comparison.
Gotcha.
But certainly, the material properties, the potential to expand and contract are addressed in our tanks designs today. Yep, okay, so with this, another disadvantage is risk of groundwater getting into these clear wells, even after we make them watertight, there's no guarantees. And we'll need to do more frequent inspections. So, switching over to at-grade reservoirs, the alternative to extending the service life. Earlier this year, you may remember we put together this graphic to help visualize the height of circular pre-stressed concrete tanks compared to the filter plant, and then cast-in-place concrete rectangular and square tanks relative to the filter plant. So advantages of the at-grade reservoirs: we've got our drinking water out of where it can be contaminated by groundwater or flood. This type of water storage strategy complies with all the current regulations and aligns with the drinking water industry best practices. It involves conventional, lower-risk construction methods with circular pre-stressed concrete providing the lowest risk, lower than square cast-in-place or rectangular cast-in-place concrete. And the result is there are facilities that the city can readily access and maintain when repairs are needed. The disadvantages are these structures are visible, highly visible, and impact views of the lake. And they require construction, operation, and maintenance of an intermediate pump station to fill the tanks. So, cost estimates, I'm sorry for the typo at the bottom. There's a period after the 9, and that should be a comma. We're talking about extend the service life option being about 21 million, at grade rectangular being at about 17, and circular pre-stressed concrete at about 13, estimated construction cost. And then you may remember there was a meeting in either February or March this year where we had a paper handout that compared the alternatives life cycle cost. And at that time, the third column of extend existing Clearwell service life was kind of a guess because we hadn't done all of these inspections and investigations. So now those numbers in the last column, in fact, I think the last time we shared this table with Common Council, we had a range of numbers because we really didn't know what was there. So the first two columns haven't changed since March. So looking out 20 years, the cost of owning these assets, making these decisions is not only a construction cost, but the cost of annual operation and maintenance. And we're comparing 16 for the pre-stressed concrete circular tanks with 20 for the square and rectangular tanks, with 26 million for extending the service life of the Clearwells.
So this would include like the frequent inspections that would be needed? Yeah.
Big difference here being right that for that third column, 20-year service life is the end of its life.
That was a great point. I was just about to make a point
First
of
two
is,
less than the-
you know, look at the second row of numbers on that table is the estimated service life.
For the storage tanks.
For the storage tanks,
For the
correct.
storage
Thank you,
tanks.
Linda.
The pumps and mechanical equipment would have a longer service life, but just the storage tanks, we would expect that there would be another capital project in that 20 to 30 year horizon where there would be cracks and maybe wall pipe penetration leaks or something else related, similar to address.
Or it
It's
could,
almost the reverse of where we were at a few months back in terms of the expectation of the cost for replacing the tanks versus extending.
I think the extending the life was always anticipated to be a higher cost, but like Linda said, we had a much bigger range on it because we didn't know what we didn't know. And I think, you know, Linda, to add to that point, you know, in that 20-ish year time frame, we could have another major rehabilitation project, or it could be to the point where, you know what, they can't be rehabbed anymore, and then we have to do one of the other two options at that point. So that service life, that estimated service life is a very important one to keep in mind as we continue to look at this project.
And then at which point, the lift station in the middle would need to be reconfigured as well. So we'd be taking advantage of the life cycle of that high lift station put in the middle of the existing ones.
So is it reasonable to assume that 20 years down the line, if we are taking the rehab option, that would be more expensive than reconstruction again?
Yes.
Okay.
when you're looking out over that longer horizon, one of the things that the PSC has been trying to make sure water utilities do is don't look out too far, because we don't want customers today paying for capacity that they're not going to use in year 30, which is kind of a different approach, but they're trying to make sure that ratepayers today are paying for benefits that they will realize, that they will enjoy. Okay, very last slide, I think, is, oh no, second last slide is, this is the compliance schedule that the city proposed to DNR and has been accepted. The first milestone has already been accomplished. We met with DNR earlier this month to discuss what we've reviewed here tonight, and we've gotten their input in this presentation that you saw tonight. The next milestone is to follow up with them by the end of October about what is the Common Council, what is the city, the community going to select and go forward with, and then by January, the end of January next year, put together a proposed action plan for addressing the non-compliant Clearwells. And then last slide. So what are we focused on right now? You may recall that in 2021, we combined the ozone equipment replacement project with the Clearwells project because these projects were on a parallel path in the city's capital improvement plan, and we didn't want contractors getting in each other's way. And in the last 6 months, concerns about the reliability of the ozone equipment remain elevated. And so the Water Utility Department of Public Works proposes to move that straightforward equipment replacement project, which is equipment inside the building, will not visually impact the community, separately from the Clearwells project. And we would work this year to purchase the ozone equipment and complete the design in 2023 and start the construction in 2023. And then we are looking forward to, in the next few months, we hope, to work with the city and the community to get whatever input we need on the Clearwells project so it can move forward. And specifically what we'll be doing kind of behind the scenes is making sure that the regulators know what's going on and share with them the city's conversation with the community, and also make sure that projects are in the DNR's Safe Drinking Water Loan Program. The deadline for that is in October.
October of this year?
Correct.
It's
How
an,
much do they-
it's an annual program, so, for construction projects, there's an October 31 deadline every year to get in kind of the next year's program, so that is an annual program.
How much assistance has historically been available through that?
It's not so much that they're providing assistance, it's that generally that those dollars are at usually a little bit lower rate than bonds.
It's a program available to communities to have below market financing. So the savings are in the interest rates.
Okay.
And then it's also, because it's the safe drinking water, it's looked at differently when doing the bond analyses, because it doesn't have to comply with the rate covenants of bonds. So it's borrowing the money from a different source with different rules and strings attached to it.
Not a grant, though. It's a borrowing. It's
Yes.
just
Different kind of borrowing.
But I gotta say, DNR at every meeting that I attend is talking about the availability of more principal forgiveness, which is grant money, through the bipartisan infrastructure law.
Oh, okay.
That's what I thought I had read about, was some forgiveness.
Linda, one more. Oh, go ahead.
Well, I was gonna ask you, Mark. So, right, we have these three different options, different cost options, and presumably the more expensive options, we're paying for that through increases in rates.
Yes.
Okay.
Absolutely. So, what you're doing is you're for $6 to $10 million, you rent a view for another 20 to 30 years.
Got it.
That's, I don't know how to more bluntly state it.
It should be blunt. So.
They're not saying no. It's just that
Here's all
there's
the
a
other
yes,
things.
but here's the price for it. A question, Linda, and if this might even be a question for Russ, but this is based on your review with the DNR. What is the Public Service Commission going to say with an alternative that is a life cycle cost of 6 to 10 million more over a 20-year period? Does the PSC weigh in on that?
Well, when we spoke with them last year about increasing the cost of a project significantly to address aesthetics, then they provided to us an example of a project where a water system needed to improve the aesthetics of a project, and the additional aesthetic improvement was $1 million over the otherwise functional, decent looking, but not very attractive version that they needed to go forward with. And the PSC for that particular project delineated that extra delta, that supplement, could not come out of water rates. It needed to come out of like the general community
That was
fund, which is
lucky
what,
one, right?
right, which is what they did.
I'm just more curious if the PSC would weigh in on this, yes or no, and I'm hearing the answer is yes. They might look at this and say, well,
Yes.
They,
Yes, they will. They will, because their charter is to make sure that people's water rates are, I'm not gonna say as low as they should be, but
When
as
they can be.
responsible as,
when they can be lower. They should.
yeah.
that's,
Along the lines of his question, I'm reading between the lines on that one that, you know, they may be willing to allow us to go to the ratepayers for roughly 13 million for precast circular. We gotta pay the difference for the rectangular. But-
Potentially.
Potentially, but I think maybe, I'm gonna clarify Mark's question and he can tell me if this is where he was going. Will they delineate between us choosing repair rehab versus new? Where the repair rehab just inherently has the higher cost, but that's the version we're going with compared to whatever the new cost would be for complete new construction.
we would have to submit for authorization to construct, and as a part of that, they will ask for an alternatives analysis, and they may well come back and say, you know, like the example Linda was talking about with the aesthetics, they may well come back and say, the ratepayers will pay this much. City, if you want to do this other route, you need to find another way.
Okay.
We won't know until we start having those communications with the Public Service Commission. But the project will absolutely require their approval to construct. Sorry, Mayor, that was all I wanted to get in.
No, I guess that was my question too, is if there's a determination about aesthetics versus operation versus the life cycle cost, would that also impact our ability, if, depending on which choice we're selected with regard to the lifeline water rate, if it's a need versus want situation, and we talk about, we know that there's gonna be an increase, and that's when we have to put our application in. Would that be a case where they're like, well, you're choosing to go the higher cost for the aesthetic benefit, then you forego this potential lifeline rate that we've been talking about for basic hygiene?
So, I'm gonna give you an answer from 5 years ago. In 2017, when we had pre-stressed concrete and we had brick fascia on it, and we met with the Public Service Commission in the pre-application meeting, and we had the cost estimate, and we said, here's this $280,000 of brick and stone fascia and things that are going to make these water storage tanks more attractive for the community. They thought that was reasonable, given the magnitude of the project.
Okay.
So it's not like you have to do everything plain vanilla. They want to, they understand you have to get along with the community, and your cost should reflect that. And also, it was very helpful that in 2017, there was a public information meeting, and the things that people specifically said they were interested in having and why were reflected in the design. So I think it's kind of a two-part thing. It's reasonable, and has the community expressed this will? And that answer is 5 years old.
Okay,
Madam Mayor,
yes.
just one other comment. The city is currently in the process and has submitted the paperwork for review on our current rate structure without the Clearwell project in front of the Public Service Commission right now, and I think you had some of that communication. So once we decide to go down the construction method and everything else, that'll be a separate package and application to the Public Service Commission.
So, separate and distinct, not reliant upon one
We
another.
need to evaluate our rates right now based on the current cost of operations within our water utility.
Okay. Thank you.
Thank you.
Thank you.
Thank you.
The Oshkosh Common Council is currently in a break. For a schedule of all GovTV programming, visit our website at oshkoshmedia.org. This is GovTV, opening accessibility and understanding of local government, helping you to be informed and involved. Also streaming live and on demand at oshkoshmedia.org and radio simulcast on Oshkosh FM 101.9. Like us on Facebook at our Oshkosh Media page. For a schedule of all GovTV programming, visit our website at oshkoshmedia.org. Please stay with us. Coverage will resume shortly. The Oshkosh Common Council is currently in a break. For a schedule of all GovTV programming, visit our website at oshkoshmedia.org. This is GovTV, opening accessibility and understanding of local government, helping you to be informed and involved. Also streaming live and on demand at oshkoshmedia.org and radio simulcast on Oshkosh FM 101.9. Like us on Facebook at our Oshkosh Media page. For a schedule of all GovTV programming,